Hi, grade sevens. This is Mrs. Nickel. Today we're going to be talking about environmental monitoring. So I'm just going to get my PowerPoint presentation loaded up here, and we are going to go through these topics about environmental monitoring. So if you take a look here, you can get a general overview of what environmental monitoring is like. You can see it involves things like bird surveys or vegetation surveys, tree health, water quality, groundwater levels, surrounding land use. We might be sampling the different kinds of macroinvertebrates that are in a pond study. All of those things are part of environmental monitoring. Now, I want to go over a little bit of my background and then talk about what is environmental monitoring, why do we do it, who actually does it, and then we're going to talk about a case study where my daughter and I actually did some environmental monitoring in our neighborhood. So, not all of you kind of have heard my story, but before I became a teacher, I actually went to the University of Calgary, and my first degree was in environmental science. So I graduated in 2000. I was the first graduating class of the environmental science program at the University of Calgary, and I learned so much about the benefits of environmental monitoring, of really having a balanced approach, and of working with lots of different scientists and social scientists of all different kinds of backgrounds. Because when it comes to environmental monitoring, you can't just be a biologist. You need to be able to do some math. You need to be able to do some ecology. You need to be able to do some chemistry sometimes. You need to understand kind of the human impacts and the human social sciences side. And so when we talk about any kind of environmental monitoring or making environmental decisions, we need to consider people from all different backgrounds bringing their expert knowledge together in order to figure out the best thing to do. So let's start with what is environmental monitoring. So this is when an environment is assessed regularly to see if changes are occurring. So originally you need to start and set a baseline. So you sample an environment and say, what is it like right now? And then if you sample it later on, you're able to see if the environment has changed. Now, we generally focus on monitoring environments that will be or are being disturbed. So if we know that there's going to be an oil sands development, for example, we might start monitoring the environment before, and then it would be monitored afterwards to see what kind of effects that would be having. That would be the same for maybe if they're going to put in a new playground. The city might do environmental monitoring on a nearby wetland to make sure that it's not being affected by, increased people traffic or other things that might have come along with that new playground being in place. So we generally focus on environments that will be or are already being disturbed. And in the past, we often have done environmental monitoring more after something has already happened, but then we miss out on kind of a baseline of what things were like before. So we are changing. There is more environmental monitoring now that takes place before environments are disturbed. But again, it's hard to find an environment that hasn't been affected somehow by human impacts. So when we do environmental monitoring, we also need to take a look sometimes at quantitative things and sometimes at qualitative. So qualitative are those description things, the things that you see with your senses, or that you taste, or that you smell, or that you can touch and feel, or that you can hear sometimes. And then the quantitative would be those measurements that we take. So that might be air quality, or the percentage of weed cover, anything that kind of involves measuring and coming up with numbers that we can quantify. That would be quantitative measurements. Now, we need to use a sampling method that's going to give us a reasonable estimate without having to count every single species. So we can't do that. We can't go and count how many ants are in a certain area. So we're going to have to come up with a sampling method that allows us to make a reasonable estimate. We also need to, or environmental monitoring involves um, a process that allows us to identify areas of concern more quickly. That's the benefit of environmental monitoring because you can take steps to mitigate, which means to either reverse or reduce any negative effects. And it also takes natural rhythms and cycles into account. So we try and monitor maybe at the same time of the year. So we wouldn't want to monitor in July and then monitor in December and say that all the changes are related to a human impact of some kind. Because, obviously our environment is a little bit different in December than it is in July, depending on what you're measuring. So we take natural rhythms and cycles into account, and we time our sampling to make sure that we're going to get data that we can compare. Different types of environmental monitoring exist, and so it involves physical monitoring, where we're using satellites to actually track changes in the landscape over time. So you can actually see how forest cover has, either increased or decreased. You might see where they've built different roads or buildings, or you can see how the size of a city has changed over time. The environmental monitoring tracks things like big picture things like changes in climate, temperature, weather patterns, and those typically look not just at the ecosystem but at the areas around it as well. There's the chemical monitoring. That's where we're looking at the quality of air or soil or water. And then biological takes a look at the different kinds of insects and plants and animals. It might even look at fungi and bacteria and say, how are those populations changing over time because of something that's going on around it? Now, why do we need environmental monitoring? So the biggest thing is, first of all, we need to take a baseline sample so that we have something to compare to later. The only way we're going to be able to see change is if we have a baseline sample that we can compare any future samples to. Now, we can't count every single animal. It's just too difficult to go out and, like I gave in the example earlier, we can't count every single ant on a street. So what we need to do is we use environmental monitoring to give us a reasonable estimate of how many of a species are found in a certain area. And again, we'll be able to track some of those changes over time and see, are their numbers increasing? Are their numbers decreasing? We use this a lot when we think about species at risk, species whose numbers are on the decline, and we do a lot more environmental monitoring to make sure that their numbers don't decline so much that they become extirpated or extinct. The other thing is, if we monitor regularly enough, we can see when positive or negative changes start happening, and we might be able to act in time. So if we wait 30 years before we notice a change, if something's been going on for 30 years, it's a lot harder to reverse or reduce its effect. Sometimes the too much damage has already been done. But if we're monitoring regularly, we might have the chance to act in time to make some positive changes. Now, who does environmental monitoring? So companies that are using land within an ecosystem often hire environmental consultants, or they might even have their own environmental monitoring departments if they're large enough. So those would be things like oil and gas companies or any kind of development companies who are going to take land and then change it, rezone it, redevelop it to be something else. Can you think of some other companies that might need environmental monitoring? It's a good question to think about. But here's the thing, every single one of us can do environmental monitoring. In fact, you and your family probably environmental monitor already. Because think about your yard. Most of you probably have grass in your yard. How do you decide when it's time to water? Well, you've kind of monitored to see that, it's no longer wet or damp, it's very dry. Maybe the leaves of the grass are starting to droop or curl up a little bit, and you say, hey, I think we need to go water. You decide when you should plant. Maybe we need to plant some more grass because there's an area that is thinning out, or we monitor the environment kind of for timing and change, timing and climate or the weather. So we always hold off here in Calgary until after May long weekend before we start planting our annuals outside. That's part of environmental monitoring and knowing when is a good time to help plants grow and establish their roots. You also might look for signs of damage by animals or insects, and then you might take steps to stop that. So you do monitoring at home as well. So it's not just the role of consultants and monitoring departments. Every single person can do environmental monitoring for the area that they live in. So my daughter and I decided that we were really curious about the berm by our house. So the berm is a really large piece or grassy area that kind of cuts off all the sound from the Trans-Canada Highway that's really close to our house. And so we often walk by the berm and we say, oh man, that berm is just covered with dandelions. And then one day we kind of asked ourselves, well, how much of the berm really is covered with dandelions? We kind of throw out that it's full of dandelions, it's totally covered, but it's not. How much actually is the berm covered by dandelions? And sometimes finding answers to this would actually be important to cities because when they're looking at weed management practices, they're going to target areas that have kind of the worst sort of infestation of different kinds of weeds. And so if you have some sampling data and say, you know, hey, this percentage of this area is covered by weeds right now, that might be able to bump it up on the priority list for the city looking at kind of controlling weeds in that area. So we asked ourselves, how can we figure out a reasonable estimate without counting each dandelion plant on the berm, but still answer the question, how much of the berm by our house is covered with dandelion plants? So we really started the scientific process by coming up with a problem, something that we wanted to address. So then we decided, well, let's use quadrat sampling to find out how many dandelions we actually have on the berm. Now, this quadrat is one that I made myself. So I used bamboo skewers and I used yarn to tie the joints. And then I used masking tape at the corners to create this 50 centimeter by 50 centimeter square. And then I broke it down into 5 rows and 5 columns so that each one was 10 centimeters by 10 centimeters. And that actually gives me an area. So when I'm making an estimate, I want to be able to have some good estimate numbers that I can use. And so I used a quadrat sample for this. Now, the quadrat sample I'm using here is a grid quadrat because it's been broken down into smaller parts. Some grid quadrats are broken down into 100 squares so that each square represents a percent. I chose to break mine down just into 25 squares. So each square represents 4% of the total. And then sometimes you can just have an open quadrat. So you would just have the outer square with no grid in between. And that would be good for just comparing maybe the number of different species if you're not as concerned about percent coverage. So different quadrats are useful for different kinds of studies. We decided to use this one so we could actually get a count, a number, so that we could calculate some percent cover. So then, as we're setting up our procedure, then we needed to consider where were we going to sample? Okay, so we had to consider disturbed areas versus undisturbed areas. So if you take a look on the left over here, the part at the top of the berm, is traveled on. So a lot of people walk along the top of the berm. So it's a disturbed area. Lots of people, lots of dogs. And you can see that the types of plants that are there are a little bit different than the slopes of the berm. So if you take a look on the right, the slopes of the berm along the side are not as disturbed. So comparatively, they are undisturbed areas because people might walk up them to get to the top, but the regular traffic would be along the top of the berm and then also down at the bottom along the sidewalk. And so we found there were sort of two disturbed areas and then this kind of mostly undisturbed area in between. So we needed to make sure that if we're going to calculate how many dandelions there are, we would need to take samples from both disturbed areas and undisturbed areas, just in case the numbers are different. So we need to figure out how many samples are we going to take. So for us, we just decided to take 10. Now, if you remember back to probability, you know that the more samples we take, the more accurate our data is. So this would just give us kind of a limited information number, but we decided to start with 10 because it was something we could do fairly quickly, and it would give us an idea, I think, of how close the numbers were. Now, where would we collect our data? This is where we needed to describe our site. And so are we going to take it from a disturbed place, from an undisturbed place? We actually decided to take 10 samples. 2 of them we took from near the pathway on top of the berm. 3 of them we took near the sidewalk at the bottom of the berm. So those 5 were all from kind of more disturbed sites. And then we took 5 samples along the sloped part of the berm. So those are our more undisturbed sites. So then we also needed to figure out how are we going to measure. So what we decided is that we would throw the quadrat onto the ground and then we'd look at each one of the 25 squares. And I'll show you this process in just a minute. If the square was at least half filled with dandelion plant leaves, we would count the square. And if the square was less than half full of dandelion leaves, it wouldn't be counted. So this is the method that we used to be able to measure how much of our quadrat had dandelions. So our first observation we took near the sidewalk. And here's how we counted our squares. So you just need to be very systematic with this. I usually start at the top corner, and we found that it was more than half full of dandelion leaves. And so we counted that square. Then we went across the top row, and there wasn't anything else. So we went down to the second row, and then we noticed there were dandelion leaves in this square. Then there were also dandelion leaves half full here, half full here. And then we went down to the next row and started working our way systematically. And in the end, we ended up counting 12 squares that were at least half full of dandelion leaves. So then we went to our second site. And so we took this one on the slope and we counted 3 squares that were at least half full. So again, we started systematically and we kind of weave our way back and forth. And we ended up with only these 3 squares that had dandelion leaves in them. Okay, so we did this process for the rest of our 8 sites, and then we compiled our data into our chart. So you can see here we have our 10 sites. We talked about where we took the sample from. So whether it was near the sidewalk, on the slope, or on top. And then we also labeled whether it was disturbed or undisturbed. And then we noted how many squares were at least half full of dandelion leaves. So now we have some data that we can work with. So those are our observations. These are our results. So now we move into the analysis part of our study. So first thing we did is we found the measures of central tendency. So if you remember back to when we did this in math this year, we need to order the data from least to greatest, and then we found the mode, median, mean, and range. So here's our data set ordered from smallest to greatest. We came up with a mode of 7 because that's the most common number that repeats itself. A median of 7 because if you count to find the middle number, it's right here between 7 and 7. So since they are the same number, that is the median. The median 7. And then our mean we calculated by adding them all up together and dividing it by 10 because we have 10 samples. and we ended up with a mean of 7.6. And just for interest's sake, we also took our range. So our range was 10. So there was a difference from the lowest number that we counted to the highest number that we counted. So the mean, median, and mode are very similar. So it is reasonable to think that for any set of random quadrats that we tested across the berm, that on average, we would expect that about 7 out of 25 squares would be filled with dandelions. So 7 out of 25 corresponds to 28%. Remember, every single square represents 4%. So 7 times 4 is 28. Or you could also do this division. So 7 divided by 25 would give you 28 hundredths, which translates to 28%. So we could say, or based on our analysis, that we would estimate that dandelion plants cover about 28% of the berm by my house. Now, we also could try to determine the area covered by dandelions. So in order to do that, we need to know how much area is covered by our berm. Well, I was not going to take a measuring tape and measure out how big my berm is. And I didn't have one of the wheel kind of distance measuring tapes. And so what we did is we, again, used an estimating method to figure out the area of the berm. So we put our quadrat down on the sidewalk and discovered that about 3 of them would fit across a sidewalk block. So that means that every sidewalk block is about 1.5 meters long. So then what we did is we counted how many blocks. So we just walked from one end of the berm down the sidewalk to the other. We counted 167 blocks. So if we multiply that by every sidewalk block being 1.5 meters, we ended up with a length of our berm of being about 250 meters. Now, the other thing we discovered was that it took 2 steps to walk across every sidewalk block. So we used this to kind of walk from the sidewalk up to the top of the berm all the way to the fence, and it took 42 steps. So we divided that by 2, which means that it would have taken up about 21 sidewalk blocks. And using that, we get an approximate answer of about 30 meters distance from the sidewalk to the fence. And so really, the berm can be thought of as this big, long rectangle that is 250 meters long and 30 meters wide. And so we can calculate the area of that to be 250 meters times 30 meters. This is the area of a rectangle, and that gives us 7,500 meters squared. So if we know that 28% of the berm is covered in plants, we can just find 28% of this total area. And that comes out to 2,100 meters squared of the berm area being covered by dandelion plants. So I hope you can see kind of the usefulness of being able to do this environmental monitoring. We can get some really interesting numbers that we can use as reasonable estimates. So the last part of an environmental study is kind of coming up with some conclusions. So first of all, it's always important to mention that we could increase the reliability of our estimate if we took more samples and added them to our data set. Now, based on our 10 samples, we estimate that about 28% of the berm is covered by dandelion plants. So this means that dandelion plants cover an area of about 2,100 meters squared. So again, this is just a place to kind of restate the findings that we found from our study. Now, dandelion plants are well established, but we realized it would be inaccurate to say that the berm is covered completely by dandelions. Now we know that that's not true. And we could do further sampling, or we could use a different method to look at other weed species on the berm to find out how prevalent they are. So we could do a transect method of monitoring. We could monitor at different times of the year. So maybe dandelions come out first, but then maybe they die off later. We could take a look at, again, what other kinds of weed species are there. Now, one thing that was curious to us, and so another thing we put in conclusions are other questions that came out of the study. So my daughter and I were really curious that there wasn't a bigger difference between the amount of dandelions in undisturbed areas and disturbed areas. So, why wasn't there much of a difference? In fact, I mean, the range was fairly close, the median was fairly close. There was a difference in the mean number. So, the mean number of dandelions for disturbed heights was much higher, but for undisturbed sites, it was lower. So, we were kind of interested. We could almost do another study to try and find out, um, maybe this undisturbed area that as we've called it, maybe it's not so undisturbed. Are there certain parts of the slope that have even less dandelions? Are there certain parts of the slope that have more dandelions? So there's all kinds of questions that we could pursue. And so this is a really good case study, not just to show environmental monitoring, but to walk you through the scientific process where we come up with a problem, we kind of make some guesses or estimates of what we expect we're going to find, which we didn't focus on as much in this one. We could have done that. Then we put together our materials and a procedure. We decide what methods we're going to use, and then we do our observations. We compile our results. We analyze those results, and then we come up with conclusions. So summarize what you found, talk about any things that you learned from the study, and then think about further questions, future questions that you could study about. So coming up after this lesson, we would like you to watch 3 other videos. So a really quick one on working to save the northern leopard frog, which just shows how an ecologist from Calgary is using environmental monitoring to keep track of the northern leopard frog, which is considered an indicator species, and she explains to you what that is. We also want you to watch a video on what is environmental sampling. And so you can learn how ecologists use the concepts of mapping and zoning to figure out where different species are found all over the world. Again, not by counting all of them one by one, but using really reliable and reasonable sampling methods. We also want you to watch a video on sampling strategies to learn about different ways of sampling with quadrats and why you would want to use these methods, or kind of which situations you would use them in. And then you are going to do some quadrat sampling yourself. You're going to make your own simple open frame quadrat with materials you have at home. You're going to sample a disturbed and an undisturbed site to compare what you see. It's really important that you read those task requirements carefully and that you follow through the instructions step by step. Submit images of your visual note pages when the task is complete. So good luck with this. I hope that we have given you some information about environmental monitoring that is useful. I know I talked for a while, but I'm pretty passionate about this stuff. It's really interesting to me, and even just being able to do that personal environmental study with my daughter was a lot of fun for us. My 5-year-old son even came out and threw the quadrat on the ground. And so anytime, we just want you to be aware of the environment, think about what's happening, the changes that are happening, think about how you affect it, and continue to be as safe as you can outside by not running into or encountering animals, that give them their space, but get outside, enjoy the environment that we have, and do your best to minimize your impact on it. Thanks for listening. Until the next lesson.